Welcome to Raise the Line with Osmosis.org, seeking solutions with leading experts on how to increase healthcare capacity so people can get the care they need during the COVID-19 crisis and beyond.
Hi, I'm Dr. Rishi Desai, and today on Raise the Line, I'm happy to be joined by Dr. Michael Whitt, Associate Dean and Chair of Medical Education at the University of Tennessee Health Science Center in Memphis. Dr. Whitt and other researchers have helped in the development of COVID-19 vaccines, so I'll be asking him about what that was like, as well as other impacts of COVID on his work and on medical education. So thank you so much for being with us today.
Yeah, it's a pleasure. Thank you very much.
So I'd like to start out just by learning more about you and what got you first interested in science and specifically microbiology.
It's kind of the classic story. I had a tremendous science teacher in high school, just really got me interested in the methodology of science, even as a high school student. I then went to the University of Kansas and had an opportunity to work in a virology lab. And really just, it kind of clicked. And, from there, I applied to graduate school and stayed in virology. I then went to Yale Medical School, where I did my postdoctoral training, also as a virologist, but really learning more about cell biology, microbes, and certainly viruses. They provide just a really easy to understand system. So that appealed to me because I don't like complex things. I like to break things down. So I'm a reductionist for sure.
That's awesome. Most people, I think, would hear your story and would say you don't sound like someone that likes simple things. You've obviously gravitated towards what most people think is quite complex. What is it about your experience? Because most students in high school shy away, and I'm putting it mildly, like some run away from things like viruses and biology and all that. And you had a great teacher. What do you think attracted you to that when most people are usually kind of fleeing in the opposite direction at that age?
I think it was just the opportunities that I was provided. And, I don't know that in high school I thought, oh, geez, I think I want to be a microbiologist. But I found things interesting and I read a lot. And it just kind of clicked. It was better than physics. It was certainly better than business. So I ran away from accounting and those types of things. It was just a good fit for me. And maybe that's just the way my brain works. I'm not sure.
And you've taught it for, I want to say, 30 years or so at the university. So what have you seen change over that time? Like, what are the macroscopic things that now we think about maybe routinely that 30 years ago was not on anyone's radar? Are there issues like that you've come across?
Well, yeah, I mean, the entire way of teaching really has changed. And, I've been at the University of Tennessee Health Science Center for almost 30 years. It'll be 30 years in July. And, the way that we used to teach was really department-based. So we would teach microbiology and biochemistry and physiology. But one of the big changes has been to embrace kind of adult learning theory. So our students are adults, postgraduates, and our brains work a little bit differently. And so that's been one of the really big changes, is going from the subject-based teaching to organ-based, all-encompassing type of teaching. We've also moved from a very passive lecture style to what we call active learning, where we provide pre-studies. And then in the class, it's really more about finding out what the students learned and what they didn't learn, and to help them navigate their way. Because what has happened over the past 30 years, an explosion of information. The rate of publications and just scientific knowledge has just grown tremendously. So, I'm in awe of our medical students and our physician assistant students who, they are able to digest and somehow put into packets all the information that we didn't know 30 years ago. It's just remarkable. And, certainly for microbiology and virology, my content each year changes pretty dramatically because of development of new antivirals. there were really very few antivirals. There was antivirals for herpes and for HIV, but we have them for many viruses now. So just keeping up with the technology has really, I think, been one of the biggest changes over the last 30 years.
It's not lost on me over the last 12 months. Everyone's vocabulary has changed. People talk about things like herd immunity or, like you said, antivirals. Like these are words that a lot of people know, and they didn't know these words or may not have felt familiar with these words before a year ago. And so in that sense, virologists and public health specialists, I think, have become in some ways like much more respected, understood, like what you do matters for the general person now in a way that maybe it felt kind of distant, before that. Have you gotten the sense that like now that people know what you do, is there more and more interest in it? Do you see more and more students wanting to pursue that or caring about that as a profession more?
Yeah, well, I'll kind of break this up into two parts. So, when I would tell our neighbors, they would ask, "What do you do?" And I would start telling them, I research viruses, and then that's about when their eyes started to glaze over. But now people are very interested. They ask good questions, and I know they're really thinking about it. And as far as students now becoming interested in infectious disease, as an infectious disease physician, that's not the highest paying career as a physician, but I think there's going to be a lot more interest in it now. I haven't necessarily seen it yet in our students, but they're honestly just trying to survive COVID and graduate and get a residency position. So it'll be interesting to see over the next 5 years the new crop of physicians coming out of medical school. Are they interested in infectious disease, epidemiology, immunology, all the things that are really kind of at the forefront now?
You've also been working on vaccines specifically. And for so many people, I think now, I mean, who knew up until now, like what the manufacturer's name was for a certain vaccine that you got, right? Let alone naming the disease that you're fighting off. People just say, "Oh, I'm getting my vaccine," but could barely articulate like anything beyond that. And now people are saying, "Oh, I'm getting my second Moderna, or I'm getting my first Pfizer, I'm getting the J&J." Like it's so part of our normal conversation now. Can you give us a peek into what does it take to make a vaccine? What did you do to help with that effort? I'd love to just get a deep dive on what was your involvement in. What are the things that most people don't know about vaccine development?
I mean, one of the things that is truly earth shattering, kind of groundbreaking, is the development of this new vaccine platform that Moderna and Pfizer and BioNTech developed, which are these messenger RNA based vaccines. Vaccine development before COVID really involved kind of two strategies. One, if it was a virus or it could be a bacteria, either involved selecting for an attenuated or weakened strain of that particular pathogen. For instance, the oral polio vaccine, one of the great success stories in vaccinology, was by passaging the virus multiple times through non-typical host cells. And eventually the virus acquired mutations and it became non-pathogenic. And that was kind of the route. Then the next level of development was utilization of subunit vaccines. So let's just take the parts that our immune system recognizes and let's just put that into our vaccine formulation. So we generate a nice immune response against those parts, and the other things, let's leave them out because they may also contribute to disease if you have everything together. So this new messenger RNA technology has provided us with the ability to very quickly pivot to new threats that we have. And for development of these, it's not that they just decided to do this the day after COVID was recognized as a threat. It was something that had been in development. But in the case of where you're working with attenuated pathogens, there is a long series of tests that go from initially small animal models, typically rodents, mice or rats, then moving up into another higher level species, eventually maybe going into primates, until eventually it gets into what we call phase 1 safety trials for humans. And that road, that path is extremely long, 20 years or more. Can you imagine us living with COVID for 20 years before we have a vaccine? So we've learned a lot about what it is that causes disease, what components we can add into a vaccine formulation to more rapidly get a vaccine to market. I'm just amazed at the developments that have been made really over the past probably 5 years or so in vaccine technology.
Do you mind saying a bit more about your role in the vaccine development? I'd love to hear about that.
Yeah. So my lab was really interested in understanding how viruses assemble, particularly for enveloped viruses. These are viruses that have a membrane that they typically acquire from the host cell. And what we learned was that we could remove the glycoprotein of this virus that I work on, which is actually a veterinary pathogen, infects primarily horses, cattle, and pigs. And it could assemble the spike protein of a lot of different viruses. And so the system that we have is a virus that expresses what we call a reporter protein. This is green fluorescent protein, so it makes cells glow green if they're infected, or they express a protein for the enzyme that makes fireflies light up at night. And this is called firefly luciferase. So we can now assemble the spike protein of SARS-CoV-2 into this virus that doesn't cause disease in humans, and we can easily assay the infectivity of that virus. And so what the vaccine companies were doing was to use this system, which we call pseudotyping, to actually test whether their vaccines were efficacious. And so that's really been our contribution. We've been working with one of the companies, Moderna, who has got one of the vaccines, generating pseudotypes of all different combinations of the variants to ask, do people who are currently vaccinated with the most recent vaccine, are they protected against the variants? So we can do this kind of in a regular lab setting. Whereas if you're working with the authentic virus, you have to do it in a special laboratory called biosafety level 3. So one, it just made it very easy and safe to actually test the efficacy of the vaccine. And we're also able to now test whether people who are vaccinated are protected against the variants. So I think it's a really neat system, and the companies have found it useful, I think.
Yeah, I mean, generally speaking, when things are safer and easier, that also translates to faster. And so clearly, this is something that we all need information on. So that's incredible work. As we've reported on, or has been reported on vaccine hesitancy, a lot of it is based on the speed at which this has been developed. And I think people equate speed with sloppiness. And having seen it from the inside, what do you say to people that say, well, gosh, the way they kind of got this done makes me really concerned about safety? Is there any merit to that? And if so, what is the merit to that? And if not, why do you think that persists?
Always something new is going to cause concern in individuals who really don't understand how things work. It's, fear of the unknown. And, that's been one of the big problems is all the misinformation that's been, on the internet and spouted by various people. So what do you say to someone when they say, oh, well, this was developed too fast, I'm not going to take it because it may cause this, that, or the other thing? What I try to do is is say, well, let me explain kind of what the components are. And so, what these vaccines do is provide an instruction that our cells are normally making. It's just instruction to make the spike protein of this virus. So, this is something that our body is normally doing. We have all the machinery needed in order to produce this one protein, and our immune system then says, oh, this is not something that I normally have made. And so we generate an immune response against it. So it's not like the old vaccines where you did have to worry about reversion of these weakened strains to the pathogen again. So sometimes that works, sometimes it doesn't work. And then people will ask, well, I hear people are getting really sick, right, after they get the vaccine. And I also try to explain that feeling bad is actually a good thing when you get a vaccine. That means your body's responding. So it's not that it's dangerous. It's not that it was rushed through, and that's why people are having some of these reactions. The technology has been tested in animals, it's been tested in people, and it's proven to be safe. So, again, maybe this is just the teacher in me. I try to teach.
I've heard the opposite too. I've heard people say, well, I've heard that, when you get a fever or muscle aches, it's because your body's responding. And when I got the vaccine, I had no response. That's why I'm worried it had no effect. And then I'm like, oh my gosh, well,
Yeah.
not in everybody. And that's where you talk about percentages. And so some of this information, it can cut both ways, because when you have a little bit of information, but then you don't take into account the fact that not everyone reacts homogenously to everything, and that these things can vary person to person, then people start misinterpreting the counterfactual in that sense.
Yeah, and you're absolutely right. People say, oh, I didn't feel bad. I don't think it worked. Or maybe they gave me water. I don't think that's true.
To me, it gets to this other issue, and I was thinking about this recently, of like how people think about institutions. You've been a part of a couple of institutions, and you growing up kind of were attracted to the institution of science and all that kind of goes with it. And in your role as an educator, I'm curious, like, how you respond either viscerally or in the classroom when people say, well, you just can't trust the science, the experts, they're always wrong, or kind of make these blanket comments. What is your kind of gut reaction to that when people say things like that, which I've heard more and more commonly in the last probably 3 years than I did in like 20 years ago?
So there is a lot of distrust for the medical profession, and certainly for, I think, science in general. I don't know if it's growing up with movies of the mad scientist. So how do you dissuade people? Well, I think the easiest way is you start providing examples of things that science has brought us and where people would be without science. The history of some of the really bad things that have happened by, I guess you would call it the scientific community, but it's more the renegades. Things certainly with the Tuskegee experiments and all the issues that are going on with race and racism. It's hard not for the general public to really distrust scientists and some physicians. It's our job now to build that trust again. That's absolutely what we have to do. And how do you do that? It's by showing that we are normal people, that we really are working for the benefit of people. It's not that we're looking to make a fast buck off of someone. It's not that, we want to take advantage of people. We're really in the business of helping people live better lives. And, that's resonated with people, I think, in certain discussions. Building trust is going to take a long time. And that, I think, is one of our challenges. We have an opportunity now to show that, yes, indeed, you can trust us and we can help. and you have to believe us at times. So it's a very tough nut to crack. And I think it's difficult to speak in language that everyone can understand. I know I find myself very often when I start to see the eyes glaze over, I go, okay, now let me whip in an analogy, of some type. And that often helps. So being cognizant of who your audience is also really important.
Yeah, absolutely. And I think more and more it's insufficient to just teach with facts. Like you have to be able to teach and also hold someone's attention, like you said. One of the things that I've realized is that like people tie together data points. Like for example, they'll see things improving. Prior to 2 weeks ago, things were generally getting better in the US. And I think people thought that that was related to the vaccine. That's a reasonable idea. I don't think it's factually correct. I think it's mostly based on behaviors. It's mostly that, our behaviors were good and therefore we reap the benefits of that. We were socially distancing, wearing masks. These are good behaviors. And then on the other side, you've got the virus, and it's got its behaviors, and it's behaving sometimes in a way that's static. So that's great. Sometimes it misbehaves and things get worse, and that's when we have mutations and variants, things like that. So a lot of this is like our behavior, its behavior, and I think that one of the things that has been challenging for science in general is to articulate a strategy that feels cohesive, but also kind of nimble enough to explain these things. Like, I think at the beginning of this, let's say 8 months ago, we talked about the vaccine in most people's minds, like, let's just wait till the vaccine gets here.
Yeah.
Now the vaccine is here, and it feels like the goalposts have shifted, even though they may not have actually shifted, but it feels like the goalposts have shifted to like, well, now we've got variants. And because we've got variants, we've got to keep our masks on, we've got to keep kind of doing this due diligence to kind of keep our wits about us so that we don't get slammed. Again, we've gotten slammed 3 times. And so I'm just curious to get your thoughts on like how to hold a population's attention. I think Dr. Fauci does an incredible job of it. But from your standpoint, like how do you hold a population's attention when it can feel like the goalposts are shifting and things are kind of like, well, you said this, but now you're saying that, that kind of thing.
Yeah, that is extremely difficult. There's just social weariness. People are tired of being in isolation and wearing masks and not being able to do all the things that they wanted to. So it's very difficult to convince a population that we could really have controlled this virus very early on by doing what we were doing a few months ago, which is really paying attention to social distancing and wearing masks and washing our hands. We learned how to do this, but it's something that we're going to have to learn again with the variants. People don't really understand, the virus is replicating, and you give it an opportunity to replicate with a little bit of selective pressure, which is maybe a mild to moderate immune response after your first vaccination. And, you think you're protected and you go out. So unfortunately, what can we do? We're going to have to learn our lesson again. And that's something I really struggle with as I see our neighbors having parties and going, please don't do that. Let's really wait till we get this under control. So I don't know. That's a really tough one. I don't know how to deal with that.
And tied to your point about neighbors, is like on a local level, you've got your neighbors that live next door to you. You've also, as a country, you have neighbors, Canada, Mexico. We have a global group of neighbors. And not every country, most countries don't have robust immunization plans at the moment. And I think that that's another thing that hasn't become part of the mainstream conversation yet, but will, because there will be a date when America seems to have hit herd immunity, whatever that threshold ends up being based on R0 and all that. But the same cannot be said for Bangladesh. And you still have travelers going from Bangladesh to San Francisco or, Memphis or wherever. And there is an opportunity for variants to emerge in Bangladesh because they're not fully immunized. And those variants, we don't have the same level of protection. And so you can quickly imagine a scenario where people say, well, let's just shut our borders down to those countries, or let's just try to blame that country, right? Like there's a lot of blaming going on. Every time it spins out of the science and into the political fields is where I feel like we all go astray and like we lose ourselves. But this will happen. Like, clearly this will happen if you look at the data and you say, well, gosh, not every country is responding. Just like you said, your neighbor's not responding the way you are. If we do this on a global level, the same thing will play out. So I'm just curious if you have any thoughts on that or how to message around that, because clearly today we're focused very much on like, how do I get a vaccine? Not too many people are asking the question of like, how do we make sure Bangladesh, and I'm picking on Bangladesh as a country only because I'm thinking of a low income country, but there are many countries in that tier where it will be a challenge to get that whole community immunized. So what are your thoughts on that?
Yeah. Vaccination in under-resourced countries is going to be a challenge. And whose role is that, I guess, is the question. Is it those governments of those countries? Well, they don't have the resources. Is it an institution like the World Health Organization? Is it some of the private institutions, for instance, Gates Foundation? Is that their job to provide the vaccine to those countries? You've nailed it, hit the nail on the head in that this virus is going to be with us for a very long time. It's very likely going to be like influenza, where we see recurring infections. So eventually there will be a level of herd immunity just because of how infectious the virus is, and people will develop immunity, but there will always be this ability to escape. And yeah, the whole socioeconomic and political content around this is extremely difficult. What we're seeing in Brazil is just devastating. They are really in crisis mode. And so I know you mentioned Bangladesh. We don't hear a lot of news about what's happening in Africa or parts of the Middle East. We probably will never know. But right now, there's just not enough of a coordinated effort to say, let's vaccinate the world, not let's vaccinate my city or my county or my country. And if I had the answer to that, I would be in a different job, I think.
Well, as a virologist, you remember smallpox
Yeah,
eradication. And
absolutely.
smallpox was eradicated in many high income countries. And they spent a lot of resources. And you could decide what you call that, but like, let's call it national security or health security. They spent a lot of resources to protect themselves against ongoing imported cases from India. And because that was so wasteful, they basically said, we can't keep doing this. So maybe it's useful for us to go and invest American dollars to get India free
Yeah,
from
yeah.
smallpox. And not only is it kind of the right thing to do to alleviate human suffering, but it's actually protective for human lives in the US. And I'm wondering whether something similar might start playing out as we start thinking and hearing these stories and getting more cases like what was happening with Brazil and the variants coming out of Brazil. It's disastrous. And if that keeps happening, then all of our efforts over the last 12 months, they won't be a waste. Definitely not, but they will be set back because now we're dealing with a different virus. And, so I think a lot of folks are just so fatigued because this has, in a way, been shaped as a sprint, albeit a 12-month sprint, which at some point stops being a sprint. But I think, as you said, I think as people start coming to the realization that it's not a sprint, there's no end date, actually. This is just our new reality. This is going to open up a lot of frustration, anger, a lot of feelings. And hopefully at the end of that, we get to a point where we're like, okay, now let's figure out the solution.
Yeah. I kind of liken this to the measles eradication effort. There was a very big push, again, primarily through the WHO and other institutions, to eradicate measles. Measles is a great candidate because, it's one of the few RNA viruses that doesn't really mutate to generate variants that can escape immunity. So immunity is long lasting, but we still haven't eliminated measles. It still causes hundreds of thousands, if not close to 1 million deaths of children every year. It's a different kind of virus, very infectious, spread by the respiratory route. Sounds really similar, doesn't it? It causes the immunosuppression that is characteristic of measles. But I think your point of this is no longer a sprint, but this is a new way of life. One of the kind of benefits that has happened is we have seen such a reduction in flu cases this year. And what does that due to? It's not because people are getting vaccinated against SARS-CoV-2. It's that we're practicing social distancing. We're practicing wearing masks. So can we do it? Yeah, we could do it. It's going to take a little bit of effort, and it's going to be for the long haul.
So one thing I'd like to then close on is, as new early stage health professionals are kind of entering the field and have entered over the last year through this very unusual year of COVID, what is your advice in terms of how they can best kind of meet the moment, especially given that your own career has kind of been amazingly well suited for the moment? What would you say to them?
This is providing a tremendous opportunity, despite the devastation and all the heartache and deaths, for our budding physicians. This is really a time for us to learn important lessons about epidemiology. And what do we need? We need better surveillance. We need better early warning systems. There will be another pandemic just because we are always encroaching on kind of new habitats. There are viruses that circulate in a variety of animals, and bats are kind of our big reservoir of choice. And so for the budding physicians, it's always to educate the public. And I think that is probably the thing that if I tell any of our students, I say, go out to your friends, your neighbors who are not in science, and just talk to them. And one, it's getting back to building the trust. And if we had a better educated public to where there's not fear, to where we're all working towards a common goal, I think that would be fantastic. That's a lofty goal, but it is something that, yes, physicians were there to treat people who are sick, but at the same time, we can educate them, and hopefully they will be able to pass that on.
Well, that's a fantastic note to end on, and something that's very actionable for all of us to go out and talk to people and have those kind of face-to-face or person-to-person interactions. So thank you so much, Dr. Michael Whitt, for being with us today.
Absolutely. It was a pleasure. Enjoyed it.
Well, I'm Rishi Desai. Thank you for checking out today's show. Remember to do your part to flatten the curve and raise the line. We're all in this together.
For more information on how you can help raise the line and flatten the curve, go to osmosis.org/COVID-19. If you like this podcast, please share it on your social channels. You can also subscribe to the series and check out all of our podcasts at osmosis.org/Raise the Line Podcast.